welcome to the new concept of heat transfer utilities. As we know that heat transfer media, they are the integral part of chemical process utilities, without which we cannot anticipate or we cannot observe any kind of a process. And we have already know that the water, different type of heat transfer fluids, etc., they are the integral part of any chemical process. Now, alone heat transfer media cannot fulfill the desired requirement. For this, we need certain other heat transfer equipments or heat transfer utilities. Now, in this particular lecture, we are going to cover with different type of heat exchanger. We will have a brief outlook about the shell and tube heat exchanger. We will give a brief outline of double pipe heat exchangers. Now, as we know that heat transfer fluid or heat exchangers, they are the integral part of any chemical process or chemical operation. Now, the basic concept of heat exchanger is to transfer the heat energy, whatever being generated, whether it is from the any kind of exothermic reaction or some sort of any external source. So, the basic concept of heat exchanger is that they are used to transfer the heat energy from one source to another, with or without letting them to contact with each other. So, this is again a very crucial aspect. Sometimes you need to let the intimate contact between the heat transfer media and the process material in question, and sometimes you don't. Now, these materials, this can be solid or any fluid, similar or different. Ideally, no external work is required during the transfer of energy using heat exchanger. So, that is one ideal aspect. So, while calculating, while designing any kind of heat exchanger or heat transfer media, this concept need to be addressed. Now, when we talk about the heat exchanger utilities, so they are typically used either heating or cooling of any kind of fluid stream. Now, let us take one example of the pasteurization of milk. Here we need to go for indirect heat exchanger. Evaporation, again one of the integral part of chemical processes. Condensation of a single or multi-component fluids, or sometimes during the recovery or rejection of heat from a system. Now again, let us take one example, like during the production of ammonia. It's a highly exothermic reaction and it is a very temperature sensitive reaction. Now, during the entire process, you need to maintain the appropriate temperature. Otherwise, your entire reaction mass will be collapsed. So, in that case, you need to continuously remove whatever excess heat being generated in due course of time. And for this, you need to, since this is a highly exothermic reaction, so for this, you need to have a proper heat exchange fluid or heat transfer media or heat exchanger device through which you can continuously extract the heat so that the reaction mass can be maintained at the appropriate temperature, whatever desired temperature. So, these are some of the important aspect of heat exchange equipment. Now, in certain cases, the goal is to disaggregate, concentrate, distillation performance. These are govern the process fluid. Now, heat transmission between fluid occurs in some heat exchangers, sometimes through a dividing wall, whereas sometimes the fluids are in the direct intimate contact. So, when we talk about these two aspects, the heat exchangers, they can be classified in two ways, either direct contact heat exchangers or indirect contact heat exchangers. Now, let us have a brief outlook about the direct heat exchanger or direct type of heat exchanger. Now, the heat exchange between two fluids occur through the direct physical contact between them. Now, this allows a direct heat and mass transfer between these two fluids because they are in the direct contact, then again the mass transfer will take place. Now, this mechanism is valid for the cases where mixing of two fluids are allowed and it poses no harm to the process. So sometimes you need to have any kind of a material in which you may introduce the direct pressurized stream. It not only serves the purpose of heat transfer, but also it serves the purpose of agitation too. One of the example is the cooling tower, jet condenser, direct contact feed heaters. Now let's have a look about the indirect heat exchangers. Now the indirect heat transfer type, they are the heat exchangers that have an intermittent heat exchange between the hot and cold fluids by thermal energy, maybe by storage, rejection through the exchanger surface or matrix. Now they can be further classified as regenerators or recuperators. The hot and cold fluid, they are passed through a regenerative solid matrix alternately. The solid matrix, they have the high heat absorbing capacity through which the colder fluid transfer the heat as a sink. Now the examples of these indirect heat exchangers are internal combustion engines, open hearth and gas melting furnace, air heaters in the blast furnace. The regenerator performance may vary depending upon the heat capacity of the matrix, absorption or release rate for heat. There are various advantages associated with the indirect heat exchangers, like high heat transfer coefficient, you may have minimum pressure losses, you may have a quick response to load variation, or sometimes high efficiency. But simultaneously, there are a couple of disadvantages. They are a bit costlier than equiparative heat exchangers. Sometimes you may experience the leakage issue. They require the perfect sealing, and this is again some sort of a costlier affair. Now let us have a look about the recuperators, the most common and widely used indirect heat exchangers. The hot and cold fluid separates through a thin conducting wall, which acts as a heat transfer surface between them. It may be like this. Here you may have a heat transfer fluid, here the surface you need to go, and this is the thin conducting wall. Let's have a couple of example like radiator of vehicle, oil coolers, air preheaters, economizers, superheaters being used in different type of boilers, condenser, etc., pasteurization apparatus, etc. Now there are several advantages linked with this type of heat exchangers, like they are easy construction, they are very much economical, they provide high surface area for heat exchanging, but simultaneously they attract certain disadvantages, like they are having the less heat transfer coefficient, less generating capacity, sometimes you may experience the clogging, scaling issues, etc. So these are the some of the disadvantages. So you need to optimize the things accordingly. Now let's talk about the industrial heat exchangers. In chemical industries, many type of heat transfer equipments are used. They're depending upon the various type of applications in question, because there are n number of type of the products are available. For this you need to have n number of different applications. Now their common duty is to transfer the heat from hot stream to a cold stream. The heat exchange devices, they utilize either conduction, convection or radiation. These three are the major phenomena of heat transfer. The basic objective of all three phenomena is to transmit the heat energy. Shell and tube heat exchangers, they make up the majority of unfired heat transfer equipment in the chemical sector. Now let us have a discussion about the different type of heat exchangers. There are tubular type of heat exchangers. This may be the double pipe, shell and tube, spiral tube type of heat exchanger, then plate and frame type of heat exchanger. Again, they offer the spiral type of heat exchanger, then lamina, brazed, gasketed. welded. Then there are extended type of heat exchanger, plate fin type of heat exchanger, then tube fin type of heat exchanger. Then regenerative, they are of two types. One is the rotary and then fixed matrix. Then proprietary, they are embossed plate, PCHE heat pipe, etc. Then specialized material like Teflon, graphite, glass, etc. they are being used. Now, when we talk about the different types, so the heat transfer equipment is classified as cooler, heater, condenser, or other term depending upon its purpose and application. Now, cooler, it's a kind of heat exchange equipment that uses water or ambient air to cool a process fluid. The other parameters can be fixed according to their requirement. Now, it entails removing the heat from the process fluid that is perceptible. Now, this is the example of evaporating cooling of industrial process and application. So, sometimes people may ask that how a wet surface air cooler works. So, the air is induced downward over the tube bundles and water flows downward along with the air, and the heat from the process stream is released to the cascading water. Now, the vaporization, this causes the heat transfer to the air stream. Now, air stream is usually forced to turn around say 180 degrees Celsius, creating the maximum water removal, and at last the fans discharge air vertically at a very high velocity. So, usually in this particular aspect, the process fluid being used as hot water and cooling fluid is ambient air. Now, let us take the example of condenser, that is the most common type of thing being used in various chemical industries. Now, this is the type of exchanger used to condense a vapor or a combination of vapors. Different type of combination of the vapor may occur in any kind of a chemical process. Now, it entails the elimination of latent heat using an appropriate cooling medium, maybe sometimes chilled water, cooling water, or sometimes any kind of synthetic fluid which can be used or which can extract the desired quantum of heat from the fluid. Now, here this is, you can see this is the vapor inlet and this is the vapor vent, and here you are introducing the coolant which can surpass through this way, and heated coolant can come out from this way. There are certain baffles to provide the maximum heat transfer surfaces, and from here you can get the condensate out. So, very, you can say, the simple type of condenser and being popularly used in various chemical industries. Similarly, one of the basic is you can always see in a chemistry lab when we perform the alcohol water solution to distill the alcohol out, because alcohol is having the lower boiling point compared to water. So, you supply the heat and thereafter this is the alcohol plus water mixture, and here you can have a condenser which is sometimes the cold circulating water, and here you can observe the drops of alcohol. So, this is again one type of simpler type of condensation phenomena. Now, there are chillers. Now, this is the type of heat exchanger that is sometimes used to cool a process fluid to a temperature lower than that which can be achieved using water as a cooling media. And in this particular operation, a refrigerant like sometimes ammonia or a freon is used. So, this is a simplest form of a chiller. Here you are having a refrigerant and this is the heat exchanger supplied with the cold water, which where you require say at a lower temperature. So you supply the little bit hotter water, and then you can get a lower temperatured cold water. Again, usual your refrigeration cycle prevails. Here you are having the condenser, then your supply power supply, then expansion valve. So we have already gone through the refrigeration cycle. So usual refrigeration cycle prevails at this particular chiller. Now let's talk about most popular type of heat exchanger, that is shell and tube heat exchanger. Now, the shell and tube heat exchanger in its many forms, they are unquestionably the most popular, most widely or routinely used unfired heat exchanger. One fluid runs within the tubes while the other flow across the or along the tube in this form of a heat exchanger. Now here you can see there are two fluids. One is the tube side fluid and this is the shell side fluid. So that is why, because it offers with the help of different baffles and a lot of choices, etc. It offers the wide spectrum of uses. Now, shell and shell covered tube and tube sheets, channels and channel covers, baffles, floating head cover, nozzles, they are the main component of any type of a shell and tube heat exchanger. You can see here, this is again the anatomy of shell and tube heat exchanger. Now, tie rods, spacers, pass partition plates, impingement plates, sealing and sliding strips, longitudinal baffle, supports and foundation are among the other components which are required in the shell and tube heat exchanger. The tube bundle, this is again the integral part of the SNT or shell and tube heat exchanger. Like parts like tubes, tube sheets, baffles, floating heat covers, split ring, tie rods, spacers, impingement baffle, longitudinal baffle, sealing, sliding strips, they make the tube bundle. You can see over here the tube bundle, which is the core or you can say the heart of any shell and tube heat exchanger. Now tubes, they are the most important component because actual heat transmission or heat transfer occurs via the tube wall. Now here you can see the bundle of tubes. One fluid circulates inside the tube while another circulates over or along the tube side here. Now tubes are usually defined by the outer diameter, that is sometimes referred as OD, and wall thickness. Now tubes are made from variety of materials including carbon steel, low and high alloy steel, a special type of stainless steel, admiralty brass, bronze, metal like copper and nickel, and their alloys in various proportions, monel, titanium, and even exotic material like heat alloys, etc., and tantalum, etc. Low fin tubes are sometimes utilized advantageously in the situation where the shell side heat transfer coefficient is very controlling, provided the shell side fluid is not frithy. Now, while selecting the tube material, there are a couple of things important. One is that uh, minimization of scale formation. Second is that non-corrosive. Third is that it should be non-reactive, etc. So there are various issues which one should address before selecting the different type of tube materials. Now these tube bundles, they are held together with tie rods like this, here you can see, and spacers. The shell baffles are positioned correctly with a spacer. Now tie rods are metal rods that are inserted into the fixed tube sheets and fastened with the lock nuts at the furthest baffle. The number of tie rods required is determined by the shell diameter. What is the shell diameter? So based on this one you can require the you can assess that how much tie rods are required. Then baffles. They provide support for the tubes while also imparting a high enough shell side velocity to provide a suitable heat transfer coefficient. Say, after guiding the baffles along the tie rods, a pair of spacer is placed over the tie rods and next baffle is installed. So, you can see these are the tie rods, these are the baffle tubes. Now, let us talk about the channel cover and the pass partition plates. The channel is used to both introduce and guide the fluid flowing inside the tube into and out of the exchanger. The heat expert usually directs the tube side flow along the tubes using pass partition plates inside the channel. Now, they are designed to fit rigidly into the grooves provided at the tube side and the channel cover, preventing the loss of fluid on the tube side from passing from one section to, say, another section. Now, here you see the concept of front channel and the rear channel. Now, this is the shell side pass partition plate, and here you see the shell fluid in, and here the tube side fluid in. And here you see, now this is the tube side pass partition plate. Now, there are various standard vessel and heat exchanger profiles. So, in multi-pass heat exchanger, the placement of pass partition plate is rather random, with the same aim of increasing the number of tubes while maintaining a reasonably uniform distribution of tube in various passes. Now, shell and shell cover. The shell forms the outer casing of the tube bundle and serves to contain the shell side flowing stream. It also serves to introduce the working fluid into the heat exchanger as well as to remove them from the heat exchanger. Impingement plates. The inlet nozzle is often provided with an impingement plate to protect the uppermost tube located just below the shell side inlet nozzle against direct impingement by the shell side fluid. So, otherwise, if it is not being there, then the wear tear may take place. Now, such impingement can cause erosion, cavitation or vibration. Now, an impingement plate must be located sufficiently below the shell's inner diameter so as to leave sufficient flow area between the shell and the plate for the flow of to discharge without excessive velocity and thereby pressure loss. Now, here you see that these are the impingement plates and these are the nozzle inlet, and this is the front section of shell and tube heat exchanger. So, this is the tube bank. Now, let us talk about the double pipe heat exchanger. The design of double pipe heat exchanger is extremely straightforward. It is generally conservative to neglect the natural convection and entrance effect in turbulent flow. Now, in laminar flow, the natural convection effect, it can increase the theoretical grades prediction GZ by a factor of 3 or 4 for fully developed flows. Now, we know that ZZ, that is the grades prediction, that is equal to DH, that is the diameter in round tubes or hydraulic diameter in arbitrary cross section ducts. L is the length, RE is the Reynolds number, and PR is the Prandtl number. So, this is usual heat transfer equation. Now, if the inner tube is longitudinally finned on the outside surface, the equivalent diameter is used as the characteristic length in both the Reynolds number and the heat transfer correlation. So, the fin efficiency must also known to be calculate an effective outside area to use in the previous equation. Now, fitting usually contributes strongly to the pressure drop on the annulus side. Now, general method for predicting this is for this usually they are not reliable, and manufacturers' data should be used when available. And usually all the manufacturers they use to supply such kind of calibration data. Now, double pipe exchangers they are often piped in complex series parallel arrangement on both the sides. The MTD to be used or has been derived by for some of these arrangement, and it is reported in the DQ Kern process heat transfer book. Now, more complex cases sometimes they may require trial and error balancing of the heat loads and rate equations for subsection or even for individual exchangers in the bank. So, that is very important. Now, let us have a look about the Baffled shell and tube heat exchangers. The method this assumes that shell side heat transfer and pressure drop characteristics are equal to those of the ideal tube bank, that is corresponding to the cross flow section of the exchanger, sometimes modified for the distortion of the flow pattern introduced by the baffle and the presence of leakage and bypass flow through the various type of a clearance they require as required by the mechanical construction. Now, usually it is assumed that various type of process conditions, as we know that all kind of chemical processes, different type of process conditions are being used. So, it is assumed that the process conditions and physical properties are known, and different type of parameters which are also should be known, which are enlisted, like tube outside diameter DO, sometimes referred as a DO, then tube geometrical arrangement per unit cell, then shell inside diameter DS, shell outer tube limit, baffle cut, baffle spacing, and number of sealing strips referred as NSS. The effective tube length between the tube sheets L, this may be either specified or calculated after the heat transfer coefficient has been determined. Now, if additional specific information, sometimes like tube baffle, clearance, etc., is available, the exact value instead of estimated or assumed value of certain parameters may be used in the calculation of some of the improvement in the calculation with some improvement in accuracy. To complete the rating, it is necessary to know, sometimes also it is required, the tube material and wall thickness or inside diameter. Now, this rating method, though apparently the best in the open literature, but it is not extremely accurate. So, while designing very complex situation, you need some sort of accuracy. So, this method predicted shell side coefficient from about 50% low to 100% high, while the pressure drop range sometimes assumed to be from about 50% low to 200% high. The mean error for heat transfer is about 15% low, that is referred to the safer side for all Reynolds numbers, while the mean error for the pressure drop is assumed to be about 5% low, that is unsafe at Reynolds number above 1000 to about 100% high at Reynolds number below 10. Now, in this particular lecture, we had discussed various aspects of heat exchanger utilities, different type of heat exchangers. We discussed about direct and indirect type of heat heat exchangers, then shell and tube heat exchangers, different type of the anatomy of the shell and tube heat exchangers. For reference, we have enlisted further suggested materials, although sometimes during the lecture we have already discussed a couple of the references. So if you wish to have a further study or further knowledge about this subject, you can see these references. Thank you very much.